For many years, astronomers have closely observed one of the brightest and most enigmatic stars in the night sky, Betelgeuse. This red supergiant, perched on the brink of collapse, has long been anticipated to go supernova, though the exact timing remained uncertain. Now, the James Webb Space Telescope has captured an extraordinary sight, the very moment Betelgeuse began to explode. This stellar death unleashes a cosmic shockwave and offers an unprecedented glimpse into the immense power of the universe, far beyond a routine space observation. This event represents a once-in-a-lifetime phenomenon, the closest supernova humanity has ever documented. What Webb has observed fundamentally changes our understanding of these cosmic cataclysms. Situated in the shoulder of the Orion constellation, Betelgeuse is no ordinary star. As a red supergiant, it is over 700 times the size of our Sun, and about 20 times more massive. For decades, scientists have known Betelgeuse was unstable, exhibiting fluctuations such as swelling, dimming, and erupting. In 2019, it suddenly faded, sparking worldwide speculation. Was this its final moment? Was it about to go supernova? With the precision of the Webb telescope, the mystery has deepened rather than been resolved. For the first time, we are witnessing real-time signs of a star's collapse, including massive energy bursts, shifting surface convection, and chaotic twists in magnetic fields. Betelgeuse isn't just dying, it is transforming before our very eyes. The James Webb Telescope has focused on Betelgeuse for months, using its powerful infrared vision to peer into layers previously hidden from any other observatory. Now the data is clear and stunning. We can see enormous convective bubbles, each the size of Jupiter, bursting on the star's surface. We observe plumes of hot gas streaming into space at incredible speeds. Hidden within the light spectrum is a distinct shockwave moving through Betelgeuse's outer layers. For the first time in history, astronomers are witnessing the actual physics of a star tearing itself apart. Not through simulations, but in real time. And this is happening a mere 642 light-years from Earth. Unlike most supernovae that occur in distant galaxies, Betelgeuse's explosion is close enough to eventually be visible during the day, shining brighter than the full moon. More importantly, its proximity offers scientists an unparalleled opportunity to study a star's death intimately, how its core collapses, how elements like carbon and oxygen are forged, and how the shockwave reshapes the surrounding space. What Webb has captured is not just a dying star, but the very process that creates the building blocks of life. The same elements that formed Earth and all of us. In essence, we are witnessing our cosmic origins in reverse. The explosion of Betelgeuse is more than just a spectacular show. It unlocks the hidden mechanisms behind galaxy formation, planetary systems, and the cycle of life throughout the universe. Thanks to Webb's advanced instruments, we can now model the final stages of stellar evolution with unprecedented accuracy. This allows us to finally understand what happens inside a star as it dies, and may help us identify the signs to watch for in other stars, potentially predicting future supernovae long before they occur. This is not just a scientific discovery but a revelation, a moment when humanity peers into the abyss of time and sees the light explode back at us. Betelgeuse's explosion is not an isolated event. It sends shock waves rippling across light years, disturbing the surrounding interstellar medium. Webb has already detected early ripples, high-energy particles moving outward, heating nearby gas clouds, and altering the star's dust halo. Additionally, there's evidence of a gravitational shift. Despite being 642 light-years away, the collapse of Betelgeuse's core may have generated gravitational waves, ripples in space-time we've only recently begun to detect. If confirmed, this would be the first time a visible supernova is directly linked to gravitational data, fundamentally changing our understanding of how light, matter, and space-time interact. As Betelgeuse collapses, one of the biggest cosmic questions resurfaces. What remains after the explosion? Will it be a neutron star, a black hole, or something stranger? Webb's data suggests Betelgeuse's collapse is not entirely uniform. There are disruptions in magnetic fields, plasma voids, and signs of asymmetric fallback, where some material is pulled back inward rather than escaping. Some astrophysicists even speculate about the existence of a transitional object, a phenomenon hypothesized to exist between neutron stars and black holes, but never observed before. If Webb has indeed caught this in the act, it would be the first direct evidence of a new class of cosmic object. Given that Betelgeuse is only 642 light-years away, many wonder if Earth is at risk. The short answer is no. The star is not close enough to harm us. However, the longer answer is more complex. The explosion will release waves of high-energy particles, gamma radiation, and expanding electromagnetic bursts. These emissions could potentially disrupt cosmic dust clouds, influence other star systems, and even affect how light from distant regions reaches Earth. Currently, Webb is closely monitoring the speed and spread of this radiation front. Even if Earth is safe, this explosion may alter the optical structure of our galactic neighborhood, changing the way we observe the universe from now on. Betelgeuse is massive, ancient, and powerful, yet it is dying, serving as a poignant reminder that even the eternal stars in our sky have limits. What Webb has captured is more than the death of a star. It is a cosmic mirror reflecting our own existence. Every living thing ends, but from that ending come new elements. New stars will emerge from Betelgeuse's ashes, and new worlds may form in the chaos left behind. This is not destruction, but cosmic renewal, and we are fortunate enough to witness it. Among the vast data collected by the James Webb Telescope, scientists discovered something unexpected: variations in the elemental composition of the material ejected by the explosion. Betelgeuse is releasing not only common elements like carbon, oxygen, and iron, but also rare elements such as technetium and yttrium, which form only in extreme stellar environments. This is significant because analyzing the ratios of these elements allows scientists to trace the life cycle of matter in our galaxy, from the cores of dying stars to the dust that forms planets and ultimately the atoms within us. Webb isn't just recording an explosion. It is decoding the chemical story of how life becomes possible. Betelgeuse, in its final moments, tells a story that began long before Earth existed. Betelgeuse will never shine again. Its place in Orion will become an expanding cloud of superheated gas and glowing debris. Yet its death is not an end, but a gift of knowledge, elements, and perspective. It reminds us that our sun, too, will one day fade, and even the brightest lights in the sky must have a final act. From this ending, however, emerges the blueprint for everything new. Without supernovae, there would be no planets, oceans, or life. Thanks to the James Webb Telescope, we can finally witness the entire cycle, from fiery collapse to the raw materials of creation. In the cold silence of space, 642 light-years away from Earth, a star has ended its life. Not quietly, but with a brilliant final roar that traveled across the darkness for centuries until it reached us. Thanks to the James Webb Space Telescope, we did not just see this event. We understood it. We observed the signs, the collapse, the detonation, not as myth or metaphor, but as undeniable fact. Betelgeuse's death was not in vain. In its final moments, it answered questions older than humanity itself. Where do the elements come from? How do stars live and die? And what will happen to our own sun as it fades? Webb has captured more than a supernova. It has captured our origin story and a glimpse of our future. So now we ask, what else is the universe ready to reveal? And are we truly prepared to witness it? Let us know your thoughts in the comments. Was this the most important stellar event of our time? And what cosmic secret might the James Webb Telescope uncover next? Subscribe and turn on notifications, because this isn't the end. It's just the beginning of what comes after the stars.